So this is number 12. Class. I read from the book of Giancoli. And the force on the wire is a maximum of 5.3 newtons when placed between the pole faces of a magnet. The current flows horizontally to the right, and the magnetic field is vertical. We don't know which way it's vertically up or vertically down. You're good. No. Okay. Wait till we're done with this problem. Okay, so the current flows horizontally to the right, and the magnetic field is vertical. So it's either up or it's down, right? The current is flowing to the right. So here's our current flowing to the right. Very nice diagram here, right? And the force is out of the page. So let's answer the first question is, what type of magnetic pole is at the top of the pole face? Well, I know this. If the magnetic field is into the pole face, it's a south pole, and if it's out of the pole face, it's a north pole. So we need to know whether the magnetic field is up or down, right? So let's set this up, right? The current is that way, index finger that way. Everybody point your finger that way, right? Okay. The force is out of the page. Everybody do that. Right now I'm flipping off somebody who walks in the door, right? Hopefully it won't be the principal, right? It's like everybody's like, yeah, right? Okay. I'd have to explain the whole vector cross product thing, right? Okay, so doesn't that mean the magnetic field, this finger here is up? Yes? Okay, so the magnetic field is how they drew it. It is up the page. That's how they knew it was up the page. And because it's going into that pole of the magnet, that must be a south pole magnet because this side here is a north pole magnet, right? It comes out of north pole magnets into south pole magnets, right? So that's the first question, is that. The second one is ILB sine theta. If 5.3 is your maximum force occurs at what, 90 degrees when sine is 1? Is that right? Okay. I'm always somewhat insecure about that, right? So then you just plug in 5.3 for this. The current we don't know. L is 0.1 meters. B is, what did they say B was? 0.15 Teslas. And you get that it's a buttload of amps, right? Yeah? What is the what? Okay, then they say you tip it 10 degrees. Yeah? You tip it 10 degrees. Why are they using 80 degrees for the angle? Well, it's not necessarily, it's not really a trig angle so much as if we take this wire and we make it 10 degrees like this. They say 10 degrees with a horizontal. It's not the angle between the wire and horizontal that we want to use. Remember, it's always the angle between the current and the magnetic field, right? Okay, and so this angle here, if this is 10 degrees, that angle there is 80 degrees, and that's the angle you want to use. Okay, now the second question, and I'm not sure that they've got it right in the solution of the book. I think it's not correct because doesn't our length change slightly? Right? But I believe they don't change the length to get the answer they have. So I'm not sure. Either that or it's such a small effect. It's a very small effect. So if they do, they get the same answer. Yeah?
But isn't it like, that's only if it's like anchored at the back of like, say they're like spherical, circular, like
yeah.
Isn't that only if they're anchored at the back of that? Whereas I thought that they could get 10 degrees or if you get 10 degrees still within that.
I think if you have like a intersection of the question is, does it really matter, right? I think it does, because if you think of a cylindrical shaft of light, right? If you tip that wire enough, it gets longer and longer, the part that's illuminated, doesn't it? Right? And I think that's the concept here, right? But I'll bet I bet they actually probably did take into account the change in length, and it's not much. 10 degrees is like not very big angle, right? So I bet it's not a big change in length. But yeah, to do that, we'd have to use trigonometry, find what the hypotenuse is now, and yeah. Are we okay on 12? Do we need to talk about 13?